So go in again. All right. All right. So we have one person telling us what was her procedure so far. All right. So if she's doing a reflection in the line y is equal to minus x, she was saying that she interchanged her coordinates and then she just changed their signs. All right. And what I was actually wanting to get at, where your points, your marks will be awarded, ladies. If you have to physically show the transformation on a Cartesian plane, I would strongly suggest you start off with drawing your mirror line. Alright, that is important, drawing your mirror line. So somebody tell me, where am I going to draw this mirror line? Y is equal to minus x. Any suggestions? Where am I drawing the mirror line? Y is equal to minus x. Anybody here recalls from last week what the line y equal to minus x looks like? Straight through the mirror. Okay, so straight through the middle of the graph. The y-axis. I mean that straight through the middle of the graph. Like that. So we're talking about a diagonal straight line which begins in this second quadrant and ends off in the fourth quadrant. So whenever we talk about the line y is equal to minus x, remember this straight line, it will pass through the origin and it will have a negative slope like this. Alright, so trying to get it to line up properly. Okay, I went too steep on that. But essentially, this is what the line would look like. Right, so this is my line. Y is equal to minus x, right? So yeah, technically, through the middle of the graph, right? Through the middle of the graph. All right. So we have the mirror line now. If I'm mirroring this green triangle in this particular line, yes, we need to get those coordinates. And if you can recall how to do the transformation via matrix technique, you can utilize the reflection in the line y equal to minus x matrix, and you can transform all your coordinates and you'll be able to get the transform coordinates and you will be able to draw in your transform triangle. Or if you're the type of person you are pretty comfortable with being able to do the transformation, as you all heard just now, Killis was saying, she took the coordinates of a point, she swapped it, and then she changed the sign, and that's because we're reflecting in the line y is equal to minus x. Alright, and if we're reflecting something, so look at it, p prime, q prime, r prime right now is in the first quadrant, it's in that positive section of our Cartesian plane. If we are mirroring this particular triangle along the line y is equal to minus x, the reflection is actually going to occur over on this side here in the third quadrant. So we're going to be drawing a triangle somewhere in here. Alright, somewhere in here. And when we draw a triangle, our reflected triangle is going to be across on this side, just like how p prime, q prime, r prime is, same orientation, same distance apart. Alright, so as Percy was saying, she took the coordinates of the point p prime, and if p prime is 6, 4, to get the coordinates of p double prime, which is our reflection. If you all can recall what I was showing you all last week, for those of you who were there during the session, we took the fact that this is the line y is equal to minus x. So if we're working with the line y is equal to minus x, what this is saying is that my y coordinate will be equal to the negative of my x coordinate. So that's why, you know, in her simple way, she said we would, wow, okay, just a second, I was experiencing some terrible lag, but yeah, this is the reason why it works, and it's still doing that. Okay, let me write it elsewhere. Okay, so the transform coordinates would be the y coordinate in particular, like I was illustrating. You would take the x coordinate and make it negative, and you will get negative 6 as the y coordinate, and then you'll take the y coordinate, make it negative, and you will get the new x coordinate. So your transformed coordinates for p prime would be minus 4, minus 6. All right, so you could do that shortcut if you like to obtain your transform coordinates and then plot them over across on this side, right? So we're going to plot the point p double prime, which is minus 4, minus 6, which is over here. All right, so you can use the little shortcut to obtain all the other points, and we'll be able to plot them, and we'll get our transformed triangle. Right, so q double prime is 4, 4, so this would become negative 4, negative 4. Wait, is it negative 4, negative 4. And r prime was supposed to be, what was r prime? 4, 8, negative 4, so this would be negative 8, negative 4. Okay, so this one is q double prime, and this one is r double prime. Okay, and now all we do connect our points. Alright, and we have our transformed little shape here. Alright, and that's that. Okay, so this is our reflection, and then line y equal to minus x. So, any questions about this before we continue? Anybody has any questions? No questions. Alright, so I just check in because, you know, sometimes you'll do something and then you'll come following week and somebody will be like, miss, that thing you was doing the other day, that was so confusing, like I didn't understand what you were doing, right? So that's why I was just asking. So like I was saying too, if you wanted, you could use your reflection matrices to transform your coordinates first and then obtain the points and plot them, right? Up to you, totally up to you, however you're comfortable working. There is no hard and fast rule because they just simply ask you to do the reflection on the Cartesian plane, alright? So that's that part. And then there's also this part D, which says to write down the 2x2 matrix for the transformation G, transformation M, and okay, look at that. So transformation G, we already talked about the enlargement earlier, alright? So let's do this and let's try to, we'll be able to make it in time so we can take a 10-minute break, alright? So transformation G was the enlargement. The matrix for the transformation G. Anybody wants to tell me what they remember was the matrix for the transformation G? If G is the transformation that enlarged PQR to P prime Q prime R prime. Anybody remembers what was that matrix? minus 2, 0, 0, minus 2. Lovely. Alright? So we already had done that part technically when we talked about the enlargement matrix. Okay, next one is the transformation M. Transformation M, which is our reflection in line y is equal to minus x. Anybody here remembers what the reflection matrix looks like for the reflection in the line y is equal to minus x? Yes, let's hear it. Lovely. 0, minus 1, minus 1, 0. And the reason why we know it's this one, we have the case where the x coordinate becomes the y coordinate and the y coordinate becomes the x coordinate, and well, basically the sign change, right? So we have G, we have M. And the part that I want to talk to you all about now, which involves some matrix multiplication, is this little piece here, which says the transformation G followed by M. And the wording of that statement is very, 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 very important when you're going to do this particular process, right? They want you to write down a 2 by 2 matrix to represent the transformation of the shape under transformation G followed by M. Alright, G followed by M. Something to make note of. Whenever they say the order of the matrices, well, the order of the transformations, I should say, this suggests to you the order in which the transformations are to be done. So they're suggesting that you are to do G first, the transformation G, and then do the transformation M. If I am doing a matrix technique to obtain the transformed triangle, alright, under this transformation G followed by M, to get this matrix, I actually have to reverse the order to do my matrix multiplication. And when I say reverse the order, I mean the transformation I did last, I need to do that. I have to have that transformation matrix first in my multiplication statement. Okay, so it might seem a little confusing at first, but to do the matrix multiplication to get the transformation matrix that represents G followed by M, right? So I'm just gonna using some shorthand here, but you don't necessarily need to, right? So this is the matrix T that represents the transformation of G followed by M. What I need to do is multiply matrix M by matrix G. I need to do it the opposite way, right? So opposite to the order of the transformations is the order of the matrices to do the multiplication. So M is 0, minus 1, minus 1, 0, and G is minus 2, 0, 0, minus 2. And to get my transformation matrix, I just need to be able to do multiplication of matrices and I will be fine. Alright, so here's what I'm going to do. Row by column. So this would be 0. Row by column, this would be a positive 2. Row by column, this would be a positive 2. And then row by column, this is 0. Alright, cool. So this is my transformation matrix. Alright, so here's what I would want you all to here's what I would want you all to do. Attempt to do the transformation. So this is something you could do afterwards, after class. Attempt to do the transformation on the original triangle PQR using this transformation matrix and see what you get. And then I want you all to do G by M instead. Get that transformation matrix and multiply the matrices and obtain a transformation matrix, and then test it out in the same way. Test it on PQR and see what you get. And hopefully it will, help you develop some appreciation for the order in which you're supposed to do the multiplication of matrices here, because something that's extremely important that we've learned before about matrices is that matrix multiplication is not commutative, and it's one of the reasons why this particular process is going to be so specific with order. Okay, so that's essentially that part of things. Right, there is another question that what I'll actually do is probably assign it to you all later for practice and go formative. So take a 10-minute break now, and in a little bit we will resume. Alright, so stay on the meeting as usual, just go take a little break and we'll be back.